Notes for Chapter 3, Section 3.1. As you can see again, at the beginning of the chapter, a lot of vocabulary. Some of this you already know, or at least maybe you think you already know. For example, parallel lines. You have forever been told that parallel lines are two lines that don't touch. Never intersect. True, almost. It's one of those half-truths of parallel lines. What's something that you've been told in the past but haven't been giving too much information because you weren't ready to handle too much information yet. So the addition to parallel lines is that they have to be coplanar and do not intersect. Well, anytime you've ever drawn parallel lines in your life, in your elementary and middle school days, you were always drawing them on a piece of paper. So they were coplanar, meaning they were on that piece of paper, which was your plane, and you drew two lines. But now these two lines have got to be coplanar in the exact same plane anywhere all the way around so that they are considered parallel lines. And you'll see in a moment when they're not, but not yet. Perpendicular lines, once again, coplanar and intersect at a right angle, or abbreviated RT angle. Coplanar and intersect at a right angle. You've pretty much seen perpendicular lines before, intersect at a right angle. If they do intersect, they're going to be coplanar all the time anyway. They have to touch and be at a right angle. Skew lines, that may be a new word. Skew lines, not parallel, not perpendicular. They are lines that do not intersect, so you've been always told that those were always called parallel lines, lines that don't intersect. But in this case, they are not coplanar either. So if you, I don't know if you can see this as well in a two-dimensional screen, but if you have this line, this red pen, and this yellow pen, these two lines are parallel. They're coplanar. They'll never intersect each other because they'll go on infinitely without touching. But now I'm going to take this yellow line and turn it this way. Okay? These two lines are never going to intersect either. This one is higher above it. This one is going this direction. This one will go forever in this plane. This one will go forever in this plane. But you can't try to tell me that those two lines are parallel. Not even close. They don't even look parallel. But the fact that you used to be told that parallel lines never intersect was not enough information. Skew lines never intersect either. So the difference in distinguishing between them, skew lines are non-coplanar and never intersect. Parallel lines are coplanar and intersect and never intersect. Coplanar and don't intersect, not coplanar and don't intersect. Parallel planes, two or more planes that don't intersect. Two or more planes that don't intersect. The floor and the ceiling are parallel planes. Hopefully your two walls in your bedroom, four walls, are two at a time, are parallel planes. They will never actually run into each other or intersect. Some notation that you need to know. Abbreviations, so you don't always have to write the whole word parallel and perpendicular. Parallel abbreviation is actually just two little parallel slashes right here. If you ever want to draw a parallel on your keyboard, there is a straight up and down line right above the return sign. If you hit shift, it's right between return and delete. So there's two parallel lines and there is a perpendicular symbol. This one means perpendicular. So you don't have to say line AB and then write the word is perpendicular to line CB. Line AB is parallel to line CD. One thing I want you to point out, parallel, I have so many students that struggle with spelling parallel. They'll put two R's in it instead of two L's, technically three L's, okay? But if you remember that this is the symbol for parallel, that's also how you spell parallel. One R, two L's right together, same as the parallel symbol. Maybe that'll help. All right, you have this handout, hopefully, so that you don't have to draw these three-dimensional figures and write out all these words. In looking at that three-dimensional box there, we don't know if it's a cube because we don't know if all sides are the same. It's asking you to name a line that is parallel, there's a symbol, to line AB and it contains D. Name a line parallel to line AB, but it has to contain point D. So we're looking at this as two or a bunch of different segments. And yes, in the diagram they're all segments, but remember segments are pieces of line. So we have line AB or segment AB right here. It has to be parallel. Well, there are 4 lines that are parallel to that. 3, 4 altogether. EF is parallel. HG is parallel. Looks a little bit awkward, but you could they're coplanar. You could put a plane diagonally through that box. DC, line DC is parallel. Only one of them fits this description because it says it has to contain line or point D. So over here, we're going to say it's line DC or CD, doesn't matter, but you do have to put the line symbol over it because it says name a line. If it says line, you call it line. If it said segment, you'd call it a segment. This time it does say segment. Name a segment that is perpendicular to line AB and contains point D. So we're looking at line AB again. It has to be perpendicular. Now you have to be told, and I'm telling you this right now, that these are all squares or rectangles. They all have right angle corners. So line AB and contains D, perpendicular. We know that BC is perpendicular and that AD is perpendicular. AE is also perpendicular to line AB, and so is line BF. Now that's crazy when you look at that in a single 2-dimension, but 3-dimensional, you know what the edge of a box looks like. If I have a box somewhere. Okay, here's my box. You know what the edges of a box look like. There's a right angle in that corner, right angle, right angle, right angle. And then over here, right angle, right angle, right angle, right angle. There's right angles everywhere on this box, 3-dimensional. Okay, but when you draw it in a 2-dimensional drawing, this looks ridiculous that you would call angle ABC a right angle. If you didn't have the whole rest of the diagram there with it, there's no way you'd call this a right angle. You would say it was obtuse. So you've got to have some context as you're looking at it in 3 dimensions, at 3-dimensional figure in 2 dimensions. So which segment this time is perpendicular to line AB, but also contains point D? Then you would say segment AD or segment DA. Either way, doesn't matter. Next up, now it's back to calling it a line. A line that is skew to line AB and contains D. It's skew. Remember, it can't touch it, but it also cannot be coplanar. We've already ruled out DC because line DC was parallel. So we have to find something that's not touching AB, never does, never will, but it has to go through point D. Well, we only have 3 options. One of them, DC, we already said is parallel. Another one, AD, line AD, which we already said is perpendicular. The only other option through point D is DH. As you can see, this one will go on infinitely this way. This one will go on infinitely this way. We're going with line DH. Or line HD, however you want to call it. And lastly, name the planes that contain D and are parallel to line, or no, not line, are parallel to ABE. And remember, when there's nothing written in front of that, that's automatically a plane. 3 points determine a plane. 3 non-collinear points determine a plane. Name the planes that contain D and are parallel to plane ABE. There might be more than one, which is why it has the S. There might not be. If I look at plane ABE, that's this whole plane. Remember, we don't include the F because you only need 3 points to determine a plane. That's the side of the box. It has to have a side that is parallel to the box. What's parallel to the box, but also goes through D? It's this plane, the other side of the box. But how do you name it? I think we need more practicing and naming some things. 3 points. You can only use 3 points, capital letters, no commas. We could choose DCG if we wanted to. We could choose DCH. We could choose HC and G. We could use HC and D. Doesn't matter, any order, any three points. Do not name it with all 4 or it will get marked wrong. More vocab. And this is probably brand spanking new vocab that you have not seen before. A transversal. We're looking over here at this diagram. A transversal is a line that intersects 2 or more, could be more, coplanar lines, but here's the key, it has to be at different points. It has to intersect 2 or more coplanar lines at different points. So this is considered a transversal because it intersects one line at this point and another line at this point. And you might say, well, how could they not intersect it at 2 different points? Well, what if I had this line and this line? You could send a transversal through it here, intersecting at 2 different points. Yes, that black line is a transversal. Now it's no longer called a transversal anymore because it didn't intersect 2 lines at 2 different points. It's all at the same. So that would not be a transversal. This one is a transversal. Corresponding angles. Corresponding angles are 2 angles on 2 different lines that are in the same position on a transversal. So if I look at angle 1, I want to find a corresponding angle, meaning looks just like it, doesn't have to be exactly the same size, but it has to be in the same position. If I pick that angle, which is above this line and to the right of the transversal, my corresponding angle with it has to be above this line, but still to the right of the transversal. This is in the upper right-hand corner of those 4 angles. So is angle 8 in the upper right-hand corner. Those 2 correspond to each other. So we're going to name corresponding angles as angle 1 and angle 8. That's one pair of corresponding angles. But they don't have to be in the upper right-hand corner. This pair, angle 4, is in the upper left-hand corner. Go ahead and find what's in the upper left-hand corner, and that would be angle 6 of a different line. Upper left-hand corner, upper left-hand corner. Angle 4 and angle 6. Go ahead and find 2 more pairs. See if you can find the other 2 pairs. Pause it for a second and come back when you found them. Hopefully your 2 pairs that you found when you came back, we now have the lower left-hand corner, angle 3 and angle 5. And we have the lower right-hand corner, angle 2 and angle 7, both below the line, but to the right of the transversal for angle 2 and angle 7. So corresponding angles has 4 different pairs when you have that sort of a diagram. 2 lines and a transversal. Now, as you can see and you're looking ahead, there's 3 different sets of vocabulary that goes with transversals. Next one, I think it's fair that they did give us vocabulary that in English makes sense. Like if something corresponds, it means that there's a connection. Like what corresponds to me in my classroom right now? The classroom right above me. You go upstairs, you turn around the corner, that classroom right above me corresponds. We're in the exact same spot, just on 2 different floors. Alternate interior. If you know the word alternate means go back and forth. If you want to alternate between pants one day and shorts the other day, alternate back and forth. That's what alternate means. Interior means it's inside, it's between. What are we between? You got to picture these as 2, I don't know, maybe railroad tracks. If those were railroad tracks, not very straight, the train would probably crash. But alternate interior angles means it has to be between those lines. It has to be inside the tracks. Here's your tracks, but they have to alternate one on each side of this transversal. So if I pick angle 3, maybe some of you have predicted this already, it has to be between the tracks, but it has to be alternate, meaning jump down to the other track and go to the other side of the transversal, angle 8. There's angle 3, there's angle 8. Alternate interior angles. Now because we're focusing on only the interior, we only have 2 pair of alternate interior. Angle 2 and angle 6 are the other pair. Angle 2 and angle 6 are the other pair of alternate interior angles. Next up, alternate exterior angles. Hopefully pretty self-explanatory. They've got to be outside of the tracks, and they have to alternate back and forth. So now you're picking angle 4, outside of the tracks, but alternate of that all the way down here is angle 7. Angle 4 and angle 7. Find the other pair yourself, write it down, and hopefully you have angle 1 and angle 5. And every time you write these, you put an angle symbol in front of it. If you answer this question as 4, 7, and 1, 5, you're getting half the credit. Yeah, good job, you found the alternate interior angles or alternate exterior angles, but not good job. You failed chapter 1 where we practiced learning the proper symbols and signs for naming things. All right, and the final one, consecutive, or sometimes also called same side interior angles. Okay, they're interior again, so we're back to interior, but it can't alternate back and forth. It has to be on the same side of the transversal. So if you put this transversal here and still talk about interior, angle 3 goes with angle 6. They're both on the same side of the transversal, but one from each side of the other line, interior. Angle 2 then goes with angle 8. We're going to practice these. I'm going to have you make a list of consecutive interior and alternate interior corresponding and alternate exterior angles. The diagram is different. This diagram, the 2 lines went this way and the transversal went almost vertical. This time the 2 lines are almost vertical and the transversal goes the other way. You still have to be able to recognize both ways. So what I want you to do is pause the video, write down every pair that you think is consecutive interior corresponding alternate exterior, alternate interior, and then turn it back on and see what you think. I'm going to pause mine too. Okay, take a look. Make sure that you have them, not necessarily in the same order, but look over your consecutive interiors, your alternate exteriors. Your corresponding is the only one that has 4 pairs of angles that are corresponding because they're not limited to interior and exterior. And then your alternate interior. If you noticed, I did put on the top of your packet flashcards. You can rip that top off and make flashcards where you maybe color in the corners of alternate interior, alternate exterior, and then on the back, write the word alternate interior angles. And I will show you that in a second if you want to make your own flashcards. One last thing I want to point out before I give you your assignment, before you start your assignment, these little markings right here. When they put these triangles on a pair of lines, that means parallel. They don't have to tell you in English or in the directions that they're parallel. They can put a pair of little triangles on the lines to make parallel. And perpendicular, all you need is a right angle symbol. One right angle symbol is sufficient because we already know linear pairs in supplementary and 180 degrees. If we know that's 90, then this has to be 90, then that has to be 90, then that has to be 90. It's the only way that it works, so that straight lines could add up to 180. So those are your parallel symbols. A perpendicular symbol is just a right angle symbol in the corner. But go ahead and make some flashcards if you want to do that to make sure that you can study your alternate interior, alternate exterior, corresponding, same side, interior angle. I'll just show you one example of what I'm talking about. Like maybe one of the flashcards you color in those 2 one color, pick those 2 a different color, maybe make a list of them, angle 3 and angle 8, angle 2 and angle 6, and then on the back of your flashcard, you would put alternate interior angles. So you could study the front and say, oh, what kind of angles are those? And then check it on the back that they're alternate interior angles. Or vice versa, look at the alternate interior angles page and see if you can picture where they would be on there. But you've got enough flashcards, and you can cut them out if you want to make any different pairs of alternate interior, alternate exterior corresponding, same side interior. I even threw vertical angles so that you remember those from the last chapter. Linear pairs. Do you know the difference between vertical angles and linear pairs yet? Those could also be part of your flashcards, so you don't forget those either. That's linear. If you're looking at angle 4 and angle 7, alternate exterior, if you colored 4 and 8 the same color, then they would be linear pair. So have fun, have a little bit of fun with that, but use it as a study guide. It might help. Good luck.